We need to determine the radius of convergence and the interval of convergence of the given series. In order to do that, we will use the ratio test, then the limit of the absolute value of an plus 1 over an, where n approaches infinity, equals limit of the absolute value of negative 2 to the power of n plus 1 times x to the power of n plus 1 over n plus 1 to the power of 1 over 4. And this whole thing is multiplied by n to the power of 1 over 4 and over negative 2 to the power of n times x to the power of n, and n approaches infinity. Let's simplify this. This equals the limit of the absolute value of negative 2x times n to the power of 1 over 4 over n plus 1 to the power of 1 over 4, and n approaches infinity. Then this equals 2 times the absolute value of x times the limit of the absolute value of 1 over 1 plus 1 over n to the power of 1 over 4, where n approaches infinity. Since n approaches infinity, then 1 over n approaches 0, then this limit approaches 1. So we get that this whole thing equals 2 times the absolute value of x. And in order for our series to be convergent, this has to be less than 1. So 2 times the absolute value of x is less than 1, then the absolute value of x is less than 1 over 2, which means that x lies between 1 over 2 and negative 1 over 2. This is the interval of convergence. And the radiuses of convergence are equals 1 over 2.